So we will continue today working on the chapters, the first chapter of dynamics. We have started yesterday to work with it. So we were defining last time the velocity, average velocity and instantaneous velocity, and the difference between average velocity and average speed. Okay. Now we will define acceleration. So acceleration of a particle also can be calculated as an average value and an instantaneous value. You have that the average acceleration can be calculated as the variation of velocity with respect to time, so delta v over delta t. And if we want to have the instantaneous acceleration, then we take delta t tending to 0, which will give us a dv by dt. Okay, so the acceleration is simply the derivative of velocity. So here, if you want, we have the three main relations we will use in this chapter. You have differential equations that relates A, V, S, and T. Okay, so first, let me just 1 minute because people are still answering. Okay, so here you can define A is the first derivative of velocity with respect to time, or the second derivative of position with respect to time. Now, if we don't want to have time in the relation, if we want to eliminate time from the relation, we know that velocity v is equal to ds over dt. Okay, so we can replace dt by what? So dt can be replaced by ds over v. Okay, so if we replace an equation of A, so replace an A equation, what do we get if we replace an A equation? A is dv by dt. Okay, if we replace dt by ds over v, okay, we get that we know that A is equal to dv over dt. Okay, so replacing dt by ds over v, we get A is equal to v dv over ds, or sometimes we write it in this way, so A ds is equal to v dv. Okay, now how you know which relation to use, it depends on the problem question. Okay, so let's say they gave you in a problem a function of s, not function of time. You will use the relation that is independent of time, A ds equals v dv. If they gave you, for example, v function of time, then you use A equals dv over dt. So you should keep in mind these relations, all these relations, and know which one to use depending on the problem we have. We will do a lot of practice on this. Okay. So now, for example, okay, let's say if we are moving in the positive direction, if my velocity, if I'm moving in this direction like this, okay, if my velocity is increasing, this means that A will be positive, okay, and if my velocity is decreasing, then A will be negative. Okay, now who will tell me if I move in the opposite direction, if I move in the negative direction, okay, if v is increasing, how will be the acceleration? Negative or positive?
Negative.
Yes, exactly, negative. So please pay attention when we say acceleration. This does not mean that A is always positive. No, acceleration means the speed is increasing. The speed is increasing. Okay, so I can now, in case v positive, if v positive, okay, then if I increase my speed in the positive direction, A will be positive. Okay, if v positive, A is positive. but if v negative, if v is negative, it's becoming more negative, so a will be negative. Okay, so if you want in 1D motion, the condition for acceleration is, so the condition is a times v equal to positive number. So when I have a times v positive, okay, this means that I have acceleration. They should all both be positive or both be negative. Okay. And of course, if velocity is constant, then the acceleration is 0. Now, just okay. So now let us see what will happen if I have constant acceleration. In school, you are familiar with equations of constant acceleration. Now we will see how to derive them. Okay? So if you have a constant acceleration, AC, and you want to get v as a function of time, then you should think, I need a relation between acceleration, velocity, and time. So which relation to use? I use A equal dv over dt. Okay? Now, I do separation of variables. What are my variables here? Because a constant, my variable are v and t. Okay, so we do what we call separation of variables. So I take dt to the other side. I get dv equals a dt. And now I can integrate the two sides. For v, I integrate from initial velocity v0 until v. And for dt, I integrate from 0 to t. Now pay attention. To know from which boundary to start, it depends on the boundary condition given. So here's what they said. They said assume v equal v0 for t equals 0. This is why we started the integration for time from 0 and the integration for velocity of v from v0. If they give a different condition, so for example, if they say v equal 10 at t equals to 1 second. Now what will be the integration here? You will integrate for time from 1 to t in this case, and you will integrate for velocity from 10 to v. So always pay attention for your boundary conditions. Okay, now if I do the integration, okay, you have constant acceleration. So integral of AC dt is AC times t, okay? Because minus 0, so it's AC times t. And for integral dv, when you integrate, you have v minus v0, okay? So you did use that velocity is v0 plus AC times t. Now, another relation for constant acceleration. If I want to find a relation that is independent of time, since I want a relation independent of time, I will use the relation that is independent of time, which is v dv equals to a ds. And the boundary conditions are for v equal v0, s equals to s0. Okay? So now I integrate v dv between v0 and v, and I integrate a ds between s0 and s. The integration of v dv will give me v square over 2. Okay, so here if I write here the integration, it's v square over 2 between what? Between which boundaries? Between v and v0. Okay, so it's v square over 2 minus v0 square over 2 equals to, from the other side, I have AC. Because AC is constant, I can take it outside of the integration. So I have AC integral ds So it's AC times S minus S0. Okay? So now, if you take 2 to the other side, and then you take plus V0 square, you get the following relation, that V square equals to V0 square plus 2 times AC times delta S. Please don't do the error. If AC is not constant, you can never use this relation. So this relation only applicable, because a lot of students do the error that even if A is not constant, they apply the relation. Only applicable if A constant. Okay? Why we cannot apply it if A is not constant? Because look, if A is not constant, I cannot take it out of the integration, and I should find it function of S to be able to do the integration. Okay? Now, another possible relation to find is to find the expression of position S with respect to time. If you want to find S with respect to time, okay, then you should use the relation involving S and T, which is ds by dt equals to V. Okay, and for constant acceleration, we already found that V is V0 plus a constant times T. So now, to find ds, I do separation of variable. I take dt to the other side. I get that integral ds, and I put the boundary condition. For t equals 0, I have s equal s0, and for any time t, I can find the corresponding position as. So integral ds is equal to integral between 0 and t of v0 plus act dt. Now, if you integrate ds, it will give you s. So you have s minus s0 from this side. So here we have s minus s0. Okay. And from the other side, you have here integration of this function with respect to time. It will give you v0t plus ac times t. So the integration is act squared over 2 plus 0.5 ac t squared. And now, if you take s0 to the other side, you get the relation that for constant acceleration, s is equal to s0 plus v0t plus half a t squared. Okay, so please remember always these equations only applicable for constant acceleration. Let us do some examples to practice on these relations. So we have a car moving in a straight line such that for a short time its velocity is defined by v equals to 0.90 square plus 0.6t in meter per second, where t is in seconds. Determine its position and acceleration when t becomes equal to 3 seconds, knowing that at t equals 0, s equals 0. Okay? So first, we have v function of time, and we need to find position and acceleration. So we should think about relations involving time. So first we have v equals to ds by dt, and a equals to dv by dt. Okay? So to find a, all I have to do is to derive velocity. dv by dt is a derivation of v with respect to time. They gave me v as a function of time, so I can derive it directly. When I derive 0.90 squared plus 0.60, I obtain 2 times 0.9 t plus 0.6 plus 0.6. Okay, and for this is the expression of a. They asked at t equals 3 seconds what is acceleration. So a at 3 seconds, I can simply replace t by its value. So it's equal to 1.8 times 3 plus 0.6. Okay, so I am done for the acceleration. Now, to find the position, to find S. To find S, I should do integration because we have V equal ds by dt. So if I do separation of variables, I get that ds equals to V dt. Okay? And now I will integrate S. So I will integrate ds. Integrate ds between what and what? Between the boundaries. Okay? Between 0. So I am interested to between 0 and 3 seconds. Okay? So here, because you just want at t equals 3 seconds, no need if you want to find the general relation. You can just directly integrate between 0 and 3. Okay? So it will give you, this will give you s at 3 minus s0, and s0 is given to be 0. Okay? Equals to, from the other side, you will integrate the function velocity, the velocity function, which is 0.9 t squared plus 0.6 t between, so this integration should be performed between 0 and 3. Okay? So if you do the integration, what do you obtain? It's equal to, if I integrate this function, it is 0.9 over 3t cubed. So it's 0.3 t cubed. And of course here, if you want, since you are integrating directly between 0 and 3, okay, you will take the value, you replace just t here by 3, okay, plus 0.6 t squared over 2, which is 0.3 t squared, and directly I replace t by 3, so 3 squared. Okay, then I should do minus the value of integral function for 0, which is 0.30 cube plus 0.3 times 0 squared, but of course it is 0. Okay, so for the second, for 0, if you replace in the integrated function, it's 0. So you can get your S at C. Okay, any question on this? So here you can see, we can see the solution here. In general, I always advise you, here in this problem, there was no need to integrate, to do, if you want, here they first found the function, because they integrate to any position s and any time t. This will be useful if you need this relation again in the problem. But here, no need to find the function then replace by 3, because we don't need this relation anymore after. But in general, I advise you to do this method because you might need to use the equation again, and you will see in other problems how I might need it in other questions. Okay, so since you might need it in other questions, it will be a good idea to first find the general equation by integrating to any time t. Then when I get the relation, I can replace t by the value I want. Okay. Now, another problem. A small projectile is forced downward into a fluid with an initial velocity of 60 meters per second. Due to the resistance of the fluid, the projectile will experience a deceleration equals to minus 0.4 v cubed, where v is in meter per second. Determine the projectile velocity and position 4 seconds after it is fired. So here, they gave us the acceleration as a function of velocity. A equals to minus 0.4 v cubed. Okay? And we want to find first velocity v at 4 seconds. So we need a relation between v and time. This is why we should think about the relation which will include v and t, which is a equals to dv over dt. And now I replace a by its value. A is minus 0.4 v cubed. So I replace it. And once I replace a by its value, function of v, now I can do separation of variables. I take v to the side of dv and dt to the other side. So I get that I have dv over v cube, okay? dv over v cube is equal to minus 0.4 dt, okay? Now I perform integration. So I will integrate this function. Here, the first side I will integrate it. So what are my initial conditions? If I look in the given, they said initial velocity is 60 meters per second. So for velocity, I will integrate between 60 and v, okay? And for dt, I will integrate between 0 and t. It integrates between 0 and t, okay? Now, what is the integral of 1 over v cube? 1 over v cube is v to the power minus 3, okay? You know that you have a general rule in math. If you have v to the power n, and I want to integrate, what is the formula? It's v to the power n plus 1 over n plus 1, okay? So here, n is minus 3. So if I apply this formula for for n minus 3, I get that the integration of v minus 3 is equal to v power minus 2 divided by minus 2. Okay? So now I have integration. So my integral is between 60 and v. Okay? So I have 1 over v to the power minus 2 is 1 over v squared. Okay? So it's minus 1 over 2 v squared. Okay? And for the other boundary, which is 60, I do minus, it's plus. So plus half 1 over 2 times يعني كلها بالdenominator. Okay, so here like this 1 over 2 v square and 1 over 2 times here 60 square. From the other side, if I do the integration of dt, okay, I get from the other side I have just minus 0.4t. So when I integrate it just between 0 and t, it will give me minus 0.4t, okay, and plus 0. So I neglect the second part is 0, so it's equal to minus 0.4t. Okay, in this way I got v function of time, and now since I am interested in velocity at 4 seconds, I can replace directly t by 4. Now, why in this problem I found the general relation before replacing? Because look, I just need this relation after, because I still need to find position. I need to find position after 4 seconds. To find position after 4 seconds, I should use what? V equals to ds over dt. So I need v function of time. This is why here in this problem, it will be a good idea to find the general relation first, because I need it after. Okay, so let us see here the solution. So as we said, first we do the separation of variables and we do the integration. Okay, you get v function of time as we did together. So this is v general as a function of time. يعني just هون they rearranged term, يعني they have taken all other terms to the other side, and to find v square, to find v you have 1 over v square اللي هي v to the power minus 2. تصير v you should do v minus 2 to the power minus 1 over 2. So when you do 1 over v square to the power minus 1 over 2, you get v. Okay, So we got v as a function of time. And the next step is to find s. So now we will use the relation that v is ds by dt. Okay? So here I do separation of variables because here this function is only function of t. I take dt to the other side. And now I integrate using boundary condition. For s, I integrate between 0 and s, which correspond to s equals 0 correspond to t equals 0. And for any time t, I have the corresponding coordinate s. So now all I have to do is to integrate this function 1 over 60 squared plus 0.8 t to the power minus half. Okay? So what you can do here, you can, you have taken calculus, yes?
Yes, doctor.
Okay, so you should know how to perform this integration. So this equation, for example, you can call it, this is a function u. So when I integrate, I need to have u prime, okay? I need to have u prime before it. And what is u prime? U prime is, if you derive u with respect to time, it's 0.8, okay? And since you don't have 0.8, you should create it if you want. So what you do times 0.8 over 0.8. You will not change anything by doing this, okay? Because it's like you are multiplying by 1. So this will be your u prime. And integral of u prime u to the power minus half. So if I have u prime u to the power minus half, and I want to integrate it, okay? It's equal, its integration will give me u to the power n plus 1, which is here minus 1 half plus 1 to the power half over n plus 1, so it's times 2, okay? So the integration gives 2 times u to the power 1 over 2. And don't forget to divide by 0.8, because you still have over 0.8. This is why you get 2 over 0.8 times your function u to the power 1 over 2. And then you replace boundaries. You replace for t equals 0 and for t equal t. For t equal t, you get it as it is. And you put minus, for t equals 0, it's minus 1 over 60 square. Plus 0.8 times 0 to the power minus 1 half, which will give you minus 1 over 60. Okay? Then you found s as a function of time. The final step, you replace t by 4 seconds to get your position. Okay? Any question on this? Okay, another problem. A rocket travels upward at 75 meters per second. When it is at 40 meters from the ground, the engine fails. Determine the maximum height reached by the rocket and its speed just before it hits the ground. So here we have a rocket in motion, and when it reaches this position for s equal 40 meters, we have that the engine fails. When the engine fails, this means what? How we can profit from this information? So it means that the engine is not doing any force on the rocket anymore. So the rocket will be only exposed to which force? To the weight, okay? If you have motion under the effect of weight, you know we are in which case? We are in the case of projectile motion. And in projectile motion, since the only force is weight, then I can write that sum of forces is equal to m times the acceleration. And here I only have motion in y direction. So if I consider y direction, I have only minus w minus weight equals to ma, and weight is mg, so minus mg equals to ma. So I deduce, so ay, so here I only have acceleration in y, okay? So ay is equal to minus g. So I am in the case which is minus 10 or minus 9.81. So I am in the case of a constant acceleration. Okay, so constant. When you have a problem where the acceleration is constant, you can apply all relations we have developed together. Okay, so I will write them here, and we will try to use which corresponding equation to solve this problem. So directly, when you have constant acceleration, you can say that v is equal to at plus v0. Of course, if we consider that the boundary condition here for t equals 0. And here this is the case. We can consider that at t equals 0, we are at a. Okay? And we have that s is equal to 0.5 times a, and a 80 square plus v0 yt, v0 yt plus, so if you want here, it's not s, we will take y because we are moving in y, plus y0. Okay, so I can use these relations, and if I want a relation independent of time, I can use that v square minus v0 square is equal to 2a times delta y. So let us see here which relation to use. First, what do I know in this problem? I know the initial position. So I know that at t equals 0, because the initial position for me is when the engine fails. Here will start my projectile motion. At t equals 0, I know that y is equal to 40, and v0, so this is y0, okay, and v0 is equal to 75, because they said when the engine fails, the velocity was 75 meters per second. Okay, and first I want to find what is the maximum height reached by the rocket. So the question is, what is the maximum height reached? What will happen at the maximum height? What will happen at the maximum height? To be able to go down again, the velocity should be 0 here. So when they say maximum height, this means that Vy is 0. So maximum height corresponds to so for maximum height I have Vy equals to 0. So here, if you want, what do I know? I know the initial velocity, I know the final velocity, and I want to find a relation between, I want to find the maximum height. So I don't know the height, SB. This is my unknown. What is the maximum height, H max? So here, do I have any information about time? No. Because I don't have any information about time, then the good idea here is to use directly this relation. Okay? So if I apply this relation here, I will apply it between what? Between A and B. Initial position and maximum height. So if I apply it between A and B, so apply between A and B, so what do I get? I get that VB square. Of course, all velocities I'm considering along y because motion here is along y. Okay, so VB square minus VA square minus VA square is equal to, A here is minus G, so minus 2G delta Y. What is delta Y? It's Y final minus Y initial here, so it's Y of B minus Y of A. And now if I replace, velocity at B is 0, so 0 minus velocity at A is 75, so 75 square equals to minus 2G minus 2 times 10 times YB minus YA, which is H max, which I want to find, minus 40. So the only unknown in this equation is H max. So when I solve, I can get directly H max. Now, if you didn't pay attention to use this formula, it will be a little bit more complex to solve, but you can do it. You can say, I will find the time t. So another method is, what is the time t when I reach B? How to find the time t when I reach B? Who will tell me how you can find this time?
Doctor, can't we use V is equal to
We,
V0 plus
yes,
AT?
of course, of course. So we can say that at B the velocity is 0. Okay, so 0 is equal to A times TB, the time at B, plus V0. So if we replace here, we have that it's equal to minus 10 TB plus V0. V0 is 75. Okay, equals to 0. So we deduce that TB is, so TB is is plus 7.5. 7.5. And then we say to find the height at this time, all we have to do now is what? Once you have the time, you replace in the equation of y function of t. Okay? So second step, once you find TB, you say I replace in y equal to half at squared plus v0t plus y0. I can get the y. So this is another method to find h max. Okay, but the first method is easier because you only need one equation. If you use the method of time, first you find tb from v equals 0, then you should replace back the t you find in the equation y equal half at squared plus v0t plus y0. So you need to do it in two steps in the other method. Now, the second question was determine the speed just before it hits the ground. So here, your rocket will go up and then it will reach a maximum height, then go down until point C. The question now is to find the velocity just before reaching the ground. So at this level. So here, what can we do? How to find this velocity v at C? Who will tell me? So here also you can use two methods. First, look, this is one motion because over the whole path I have the same acceleration. A is minus g. Okay, so now you can apply your relations or between A and C or between B and C. But I propose to use conditions at A because they are given. So if you did calculation error for B, it will not affect your result. So we can apply between A and C any relation we want. So here, you know that the easiest equation here to use, because I don't have time, is to use the relation independent of time between A and C. So as we did between A and B, we can do between A